You know you're watching The Hustle TV. Planet Earth, Mother Nature, Gaia, whatever you call her, goes through many changes and catastrophes. This planet, on which we call home, often endures what its inhabitants cannot. Throughout Earth's 4.6 billion year history, there have been five major mass extinction events. They include the Ordovician mass extinction, the Devonian mass extinction, Permian mass extinction, Triassic Jurassic mass extinction, and the Cretaceous Tertiary or the KT mass extinction. These were only five of the events that could and have caused severe change to life on Earth and the health of the planet and its inhabitants. About 320 million years ago, when Gondwana, Laurasia, and intervening terrains collided, they formed one supercontinent called Pangaea, which was about 90% of all landmass. Between 195 million to 170 million years ago, during the Jurassic period, when the Central Atlantic Ocean opened, Gondwana, what we know as Africa, South America, India, Australia, and Antarctica, broke away from Laurasia, Eurasia, and North America. Then, about 150 million years ago, it separated where India broke away from Antarctica and Africa and South America rifted. A mass extinction event can be defined as a time period in which a large percentage of all known living species go extinct. There are several causes for mass extinction events. These include eruptions high on the Volcano Explosivity Index, the VEI, meteor impacts, geological catastrophes, climate change, but in no way limited to these. To name a few other causes, geomagnetic excursion events, or fulcrum reversals of the magnetic poles, grand solar minimums GSMs, huge solar flares, micronova or supernova of the sun, our star. The Ordovician mass extinction event, 440 million years ago. It was the first mass extinction event of the Paleozoic era. It saw a die-off of 85% of all life on the planet. The cause of this is thought to be continental drift and the effects of the change of climate, which happened in two pulses. The first pulse was an ice age where many species could not adapt quickly enough to survive the harsh cold climate, and the second was where the ice age ended and sea levels changed and oxygen content in the seas was lowered, preventing many species from surviving. It's one of the lesser known geologic spans in Earth's history, 448 to 443 million years ago, where arthropods and vertebrates expanded their presence in the oceans. It was the second period of the Paleozoic era, preceded by the Cambrian and succeeded by the Silurian, Devonian, Carboniferous, and Permian periods. Your temperatures average 120 degrees Fahrenheit globally, and ocean temperatures at the equator may have been as high as 120 degrees Fahrenheit. Vertebrate marine life included Arandaspis, Atraspis, the first jawless, lightly armored prehistoric fish. During this time, if land plants existed, they were microscopic green algae floating on ponds and streams, also with microscopic fungi. It wasn't until the Silurian that the first terrestrial plants occurred. Plunging global temperatures with lowered sea levels killed a large number of genera, though marine life as a whole recovered by the start of the next period. The second mass extinction event, the Devonian, occurred around 375 million years ago and saw about 80% of all life eliminated. Also occurring in the Paleozoic era, it happened rather soon after the Ordovician mass extinction. As the species on Earth were beginning to adapt again and life flourish, there was first a blow to aquatic life on Earth. Many believe it was due to many ocean plant species adapting to life on land, leaving fewer autotrophs to create oxygen for the remaining sea life. They also believe this had a second effect by removing much more carbon dioxide from the atmosphere so quickly, lower temperatures, and the land species that lived then had a hard time adapting. The second is more of a mystery, and the exact cause still unknown, but it may have included meteor strikes or volcanoes. It was during the Devonian period that lobefin fish adapted to life on dry land. The two best candidates for the tetrapod, four-footed vertebrates, are Acanthostega and Ichthyostega. They possess 7 or 8 digits on each foot, different to the five-finger, five-toe body plan on Earth today. Worms, flightless insects, arthropods, and other invertebrates also colonize the dry land. Acanthostega, one of the first tetrapods. Global sea temperatures around this time were 80 to 85 degrees Fahrenheit compared to the 110 degrees Fahrenheit of the Ordovician era. The third mass extinction event of the Paleozoic era was the Permian mass extinction event, where so much of all life on the planet was ended that it's termed the Great Dying. An estimated 96% of all life on the planet perished during this time, around 250 million years ago. It is still a mystery what caused this event, as scientists seek varying hypotheses. Newer research points to a microbe from the archaea domain that flourishes when methane is high that may have killed life in the oceans. Others believe asteroid impacts and volcanic activity increase methane and basalt in the atmosphere and decrease oxygen in the atmosphere and may have suffocated life and brought a quick change to the climate. It is the most likely culprit. Early synapses reptiles, an anatomical term denoting single hole in the skull behind each eye, like the Varanops and the Dimetrodon, resemble dinosaurs and crocodiles. Also, the archosaur, destined to become the first dinosaurs of the Mesozoic era. It is during these times that pteropsids or mammal-like reptiles first appeared. After the Paleozoic era ended, the Mesozoic era began. It had taken life 10 million years to recover from the last event. The Triassic-Jurassic mass extinction occurred during the last 18 million years of the Triassic period, around 200 million years ago, and was a combination of many smaller extinction events, where nearly half of all life on Earth died. The cause of these smaller events have been attributed to volcanic activity and basalt flooding. The gases spewed into the atmosphere by these volcanoes also created climate change that affected sea levels and possibly the pH of the oceans. This period saw the development of dinosaurs, fish, marine reptiles, mammals, flying animals, and various plant life. During the Triassic period, the entire Earth was joined as one supercontinent called Pangaea. There were no polar ice caps, and the average temperature was well over 100 degrees Fahrenheit. It is known that a large number of flood basalts happened in South America about the time of the Triassic-Jurassic mass extinction. The fifth major mass extinction, termed the KT mass extinction, saw nearly 75% of all life eliminated. occurring about 65 million years ago. It is possibly the most studied and understood. It became the line that separated the final period of the Mesozoic era, the Cretaceous period, and the Tertiary period of the Cenozoic era. It is also responsible for the disappearance of dinosaurs from the planet. The cause for this mass extinction was a major asteroid impact that sent huge amounts of debris into the atmosphere, which blocked the sun and caused an impact winter. This changed the climate greatly across the entire planet. In layers of rock dated to this time from various parts of Earth, unusually high levels of iridium, an element found in space debris such as asteroids, comets, and meteors, have been found. The Cuban-born Luis Alvarez, a physicist, in 1980, along with other researchers, had been investigating sediments from various parts of Earth laid down during the time of the Katy boundary, when they discovered unusually rich levels of iridium. Researchers found the remains of a huge crater in the Chicxulub region of Mexico's Mayan Peninsula. The crater's diameter was over 100 miles and caused by a comet or meteor between 2 to 4 miles wide. If you enjoyed today's video, please like and share that others may get to see this video, and I may also bring other content like this for you in the future.